and welcome to Tactics. So in the previous video I have already told you that the perceptron model has no solution for the XOR problem. So what is the XOR problem? So XOR is also known as exclusive OR, and if we have two binary inputs A and B, that is if we have 0 0, 0 1, 1 0 or 1 1, then we get output as y, that is 0 1 we get 1, 1 0 we get 1, and this is 0 and this is 0. So we can write y as a bar b plus a b bar. So when both the inputs are same we get 0, and when these are different we get 1. So the perceptron the perceptron is unable to is unable to learn to classify the input. So it cannot classify the input so that they get the correct label. So I will tell you how this happens. Correct labels. So we can write this as a mapping. For example, we can write this as 0 0 goes to 1. We do not goes to 1. 0 1 goes to 0. 1 0 goes to 0. 1 sorry, and 1 1 obviously goes to 0. So if we make a perceptron model which has two neurons and with the inputs x1 and x2, with the weights inputs x1 and x2, and the weights of these, let's say, are w1 and w2, and we produce this as output. We write y as x1 times w1 and x2 times w2, plus add the bias term. So when we have 0 0 as input we should get 1, when we have 0 1 we get 0, and so on. So taking the following instance of the parity, these parities, we have the following four inequalities. So the first inequality, w1 plus w2 must be greater than or equal to b, that is bias term. 0 must be greater than or equal to b. Third one is w1 must be less than b, and fourth one is w2 must be less than b. So this means that the perceptron, that which has the two neurons, this one and this one, cannot adjust its weight. They cannot adjust these weights to separate the 1 and 0 as they come in the XOR. So I will tell you how the inequalities, which are the inequalities do not hold. So looking forward to the first inequality. So the first inequality A holds, first one holds if x1 is equals to 1 and x2 is equals to 1, which goes to 1. X1 is 1 and x2 is 1, which goes to 1. So we will get that since x1 is 1 and x2 is 1, we get w1 plus w2. w1 plus w2 must be greater than or equal to b. So we can get 1 as the output only if w1 times x1 plus w1 times x1 plus w2 times x2 is equals to w1 times 1 plus w2 times 1, which equals to W1 plus W2 is greater than equal to B, which means that this one is true. So looking forward to the second inequality, we have the second equality holds since if we have x1 equals to 0 and x2 is equals to 0, and this produces an output as 1. So we can get 1 as an output only if x1 w1 times x1 plus w2 times x2 is equals to, this is equals to, since x1 and x2 are 0, we get 0. So this is greater than or equal to b. So here is our second inequality. So the third inequality holds if 1 0 corresponds to 0, and this happens when w1 x1 plus w2 x2 are w1 times 1. So this input must be 1 and second input must be 0. So when it's multiplied, it gets, second one gets nullified, and this equals to w1. And for the perceptron to give 0, and for the perceptron to give 0, w1 has to be less than the bias, that is this one. And the fourth inequality is derived in a similar fashion to the C, third inequality. So by adding the A, so by adding the first one and the second one, we get W1 plus W2 must be greater than or equal to 2B. You can look at the first inequality is this and second one is this. We can, when we add these two, we get W1 plus W2 must be greater than or equal to 2B. And by adding 1 and 2, and by adding the third and fourth, we get W1 and W2 must be less than 2B. So this is easy to see that the system of inequalities has no solution. The system of inequality has no solution. So what this means is that our perceptron model, this means that the perceptron which was claimed to be contendent, means this could be used as a basic building block model, perceptron which was claimed to be contendent, means basic building block for what? General artificial intelligence, general AI, could not you can say could not even learn logical inequality. So what the basically ZOR is? ZOR is the logical inequality, and these four inequalities have to be satisfied simultaneously. And you saw that the fourth one has, the system inequality has no solution. So the whole system has a no solution. So the perceptron is unable to classify the input, so it cannot classify the inputs. So it cannot distinguish between 0 0 0 0 0 to get 0 and 0 1 to get 1. So these cannot get the correct labels, and hence it cannot provide the solution for the ZOR problem. So this was thought to be the need. So this was thought to be the need for the multi-layer perceptron. So the proposed solution was to make a multi-layer perceptron, so that it can classify and adjusts its weight to get the correct label. So in this video what we learned is basically how the perceptron model fails in solving the XOR problem and need for the multi-layer perceptron. So this is the end of the video. So thank you for watching this video, and if you like the video, you can press the like button, subscribe and share it with your friends. Thank you.